All right, so one-to-one property for b is greater than 0 and b is not equal to 1, b to the x equals b to the y, if and only if x equals y. What they're basically saying is if you can get the bases the same, for example, 3 to the x equals 3 to the 5, then you can say that the exponents are the same, x equals 5. Okay, and so the first way we're going to solve this is we are going to get these to the same base. And then once we get them to the same base, we'll just set the exponents equal and we can just solve a regular algebra equation. And so what you're looking for is a common base. If you look at this first one, we have a 36 and a 6. Well, 36 is a multiple of 6. More importantly, it is 6 to an exponent, okay? Specifically, it is 6 squared. So I'm going to rewrite my 36 as 6 squared. X plus 1 equals 6 to the x plus 6. All right? You do have to remember your properties of exponents here. What happens when I have a power to a power? What do I do with those exponents? Yeah, I multiply them. So for this, you have to actually multiply it through. Okay, you have to multiply that 2 through. So I have 6 to the 2x plus 2. I just multiplied exponents. Equals 6 to the x plus 6. Once my bases are the same, I can set the exponents equal to each other. So I can say this is equal to this. 2x plus 2 equals x plus 6. Take your numbers to one side, variables to the other. Cancels here, cancels here. 2x minus 1x is x. 6 minus 2 is 4. X equals 4. Wait. And you can check these. You can put it into your calculator if you want to.
So we don't have to write it out. We just have to write x equals.
Right. So you can check it. 36 to the 4 plus 1. Does that equal 6 to the 4? I did the math.
What is that?
So 4 plus 6. There we go. Oh, and I'm just, there we
Well,
go.
that's how you check it?
Yeah, 36 to the 5th equals 6 to the 10th. Should. Next one. So if you look at this one, I have a 1/2 and a 64. All right, those actually are both base 2s. Those are both base 2s. So if I take the 1/2, that is 2 to the -1. All right, and the 64 is actually 2 to the 6th. All right, so those are both base 2s. 1/2 is just 2 to the -1. 64 is just 2 to the 6th. 2 to the 6th. And so once again, I'm going to multiply. I have 2 to the -c equals 2. 6 times 1/2 is just 3. All right, so now that I have my bases the same, I can set these equal to each other. -c equals 3. Divide both sides by -1. C equals -3. So we've talked about that bases cancel out bases. So a log base will cancel out an exponential base, and an exponential base will cancel out a log base. So if you can just get it to just one log on one side or the other, or one base on one side or the other, you can cancel it out using the inverse, whatever it is. So in this case, they have log base 2 of x equals 3. Well, I can take both sides with a base of 2. 2 to that power and 2 to this power. I just made a base of both of these. This 2 in the base cancels out this log. It's gone. You just have an x. And then you have 2 cubed, which is 8. So I know that x is 8. So like bases of exponents cancel out like bases of logarithms. All right? Like bases cancel out like bases. And so that's what we're going to use to solve these next few problems here. We're going to look for what the base is and use that to cancel it out. The key is you have to have the log by itself before you can do this. So if the log is not by itself, you have to get the log by itself. If you have multiple logs, you have to condense before you can do this process. So let's look at this next example. Natural log of x equals 6. What is the base of the natural log? What is my base here?
8.
10.
Okay, so the base of ln is always e. So we are going to use e to get rid of it. We're going to take e to this side and e to that side. On the left-hand side, those cancel. I have just the x. On the right-hand side, I have this, which is an actual number. And in your calculator, using that little key we just found, you can say second or shift ln e to the 6th power, and you will get, if you round to 2 decimal places, you should get this. On the next one, first of all, my log is not by itself, okay? So I want to get my log by itself. I have this 6 over here, and I have this 2 right there. I need to get rid of it.
Can you just add those together?
You can't add them together, but because the 2 is being multiplied, but we can move over just like we would algebraically. So I'm going to subtract my 6 first. That's going to cancel on this side. I have 2 log of 5x equals 12. Then I am going to divide both sides by 2 to get rid of that. Cancels there. I have log of 5x equals 6. Now, if I do not see a base and it is log, what is my base of my common log? 10. So I am going to take both of these with the base 10. 10 to the log of 5x equals 10 to the 6th. On the left-hand side, these will cancel. I have just 5x. Over here, I have 10 to the 6th. Divide both sides by 5. You're going to get x equals 10 to the 6th divided by 5.
Why?
That is going to be 200,000. Okay, so the question was, could you expand first? As long as you expand and only keep one log. So by that I mean you wouldn't want to expand with a plus or minus because then you've defeated the purpose of doing this. You have to have only one log to be able to do this. But I can expand this using that 3. I can move that 3 in front. So I have 3 log base 8 of x equals 12. This will keep my numbers smaller. If I didn't do this, then at the very end, I would have to take the cubed root to solve. So I can just go ahead and do this piece of it. Divide both sides by 3. I get log base 8 of x equals 4. And then what is my base here? 8. And so I take both of these with a base 8. That cancels out. I get x equals 8 to the 4th power, which is going to be 4,096. So the key here is you have to have only one log before you can do anything with this, okay? Well, I say only one log. Only one log per side, okay? So you have to have only one log on the left, only one log on the right in order to do this, all right? And so on the left-hand side, we're good to go. Log base 4 of x, he's all by himself. But on the right-hand side, we have multiple logs. We have to use our condensing to do this, okay? And so we're going to look and say, okay, well, this is a plus sign. How do I condense these to one log? Yeah, I'm going to use multiplication. So I'm going to leave the left side alone. And on the right-hand side, I'm going to say log base 4 of 3 times x minus 2, okay? Now I have one log on the left and one log on the right. I can now use my base to cancel these out. What is my base here on both of these, which is the only way to do this? It's a 4. So I have 4 to this guy right here. And I have 4 to this thing on this side. They both cancel out. So this is actually really simple to solve these. My 4's cancel here. My 4 base 4 cancels here. I get x equals 3, x minus 2. Distribute, solve, right? So I'm just going to distribute this guy. X equals 3x minus 6. Subtract 3x over. Negative 2x equals negative 6. Divide by negative 2. X equals 3. Look at B. Example B here. I currently have one log on the left and one log on the right. Like I already have it where I need it. I don't have to condense here. So I can go ahead and do my, and I just write it like this. So this is 3, that's my base, and that's my exponent. Or you can rewrite it if you want to. My new base on both sides is 3. On both sides it cancels. I have x squared plus 3 equals 52. Subtract your 3 from both sides. X squared equals 49. Because it is x squared equals 49, don't forget when you take the root of both sides, you have to consider the positive and negative root. Just like with logarithmic equations, with exponential equations, like bases cancel out each other, okay? So I have a 4 to the x equals 13. If this were 4 to the x equals 16, we're good to go. But it's 4 to the x equals 13, there's a problem, all right? So I'm going to use logarithms to cancel out each side. I am going to use log. There's 2 ways to do this, actually. So if I do log base 4 of 4 to the x equals log base 4 of 13, okay? My log base 4 and my exponential base 4 cancel each other out, okay? And I have, well, x is going to equal log base 4 of 13. You could do change of base here, right? You can just say log or natural log of 13 divided by log of 4 in your calculators, and you will get the answer. The answer will be 1.85.
Seems easy.
Right? The way they show it in the book is they just do the log of both sides. So I'll show you that way as well. So we have 4 to the x equals 13. They just do common log of both sides. All right? See there? Common log of both sides. And then they expand it. Move your exponent out here. X log of 4 equals log of 13. And then they divide by log 4. You'll notice, lo and behold, that is the same answer, right? So either way you do it, you can either use the base of the one you did and then do change of base at the end, or you can just do the log of both sides and expand, and it'll actually tell you what your change of base should be. It's log of 13 over log of 4. So either way will work. It doesn't matter. You can do it both ways. Now for this next guy, what do you think I'm going to use to get rid of it? I'm going to use natural log. So I'm going to say the natural log of both sides for their natural log of 6. On the left-hand side, the natural log is a base e, so those cancel. And I just have 4 minus 3x equals ln of 6. That is an actual number. So I'm just going to solve for x. Subtract 4. I have negative 3x equals ln of 6 minus 4. Divide the whole thing by negative 3. In your calculators, it will do order of operations, which means you have to do open parentheses. Natural log, it's going to open parentheses here. Close it after the 6. Subtract 4. Close parentheses. Divided by, you're going to have to use your little negative 3. You shouldn't have to do parentheses there, but you have to use your negative button, not a minus 3. Okay? It's not minus 3. It's divided by negative 3. There's a difference. So you should get 0.74. That's a 7. Snugly 7. But it's a 7. All right. So try it. Bottom of page 192. Just do A and C. On this one, you don't have the same base. So really, the only thing you can do is do like a natural log or a common log of both sides and expand it and then solve for x, okay? So like for this one, I have 4 is my base here. 3 is my base here. If they have different bases, you cannot just do the base of both sides, okay? So you have to use either ln or natural log, common log. It doesn't matter which one. They used ln, so we'll do that. Natural log of both sides, which means I can expand and I can get this out of the exponent, which is really what I want to do. So I'm going to have 3x minus 1 times the natural log of 4, and 2 minus x times the natural log of 3. So now I want anything that's a variable on one side and anything that's a number on the others, pretty much, all right? In order to do this, I really need to distribute through so I can get those things out. So I'm going to distribute this guy through, and I'm going to distribute that one through. So I have 3x ln of 4 minus ln of 4 equals 2 ln of 3 minus x ln of 3.
This is supposed to be 2 minus x.
All right, so when you have something like this, you want everything that has an x on one side and everything that doesn't have an x on the other. So what I'm going to do is I'm going to move this guy that has an x over to the other side. Okay, and so on the left-hand side, I have 3x ln of 4 plus x ln of 3. That's a 3 there. Okay, move that guy over. Does that make sense? And then I want everything that doesn't have an x on the other side. So I'm going to move this ln of 4 over here. So on the right-hand side, I have 2 ln of 3 plus ln of 4. Okay? So far, so good? And now I can factor. I have an x in both of these. So I have an x here and an x here. I can factor it out. So I can take the x out, and I have 3 ln of 4 plus ln of 3, right? I just took the x out, equals 2 ln of 3 plus ln of 4. Now I can divide by this whole group, and I'll have x by itself. All right, so my answer here, and I'll tell you what they did in the book. They actually bumped this to exponent and bumped that to exponent. It doesn't really matter if you're using your calculator. You can just say 3 times. So in your calculator, you're gonna want to use parentheses here. You're gonna say 2 times ln of 3. Close those parentheses, plus ln of 4, and it's gonna open, so close those, and close that guy. Divided by, and you want open parentheses, 3 times ln of 4, it's going to open after the ln, plus ln of 3, it's going to open there, close, close. And you should get, what, 0.68? Now, another way to do it is to condense, okay? Another way to do it is to condense. So what they did is they condensed this right here. They did ln of 3 squared times 4, right? Everybody see that? Right? They just moved that up and then combined with multiplication. And then on the bottom, ln of 4 cubed times 3. Right? Does that make sense? So they did that. And so they did the natural log of 36 over the natural log of 192, which is fine too. It doesn't matter. I mean, ln of 36 over ln of 192. You can do that too. You should still get 0.68. So you can check yourself. If you do it all out in your calculator, you can go back and condense and put that in your calculator and make sure you get the same number.